Welcome again to Snorkel Science Talks, a series where we interview AI thought leaders and discuss themes around making machine learning practical. And today we are very fortunate to be joined by Ines Montani, who is a co-founder of Explosion and their nearly ubiquitous library, Spacie, and an active speaker, teacher, and thought leader in the community. So thank you so much for joining us today, Ines.
Yeah, thanks for having me.
So we always like to start with a little bit of background, and I know that you have an interesting one in terms of machine learning. Give us a brief description of how exactly you came to this field.
Yes, you're right that I don't really have the typical computer science background. I've always been into computers. Like I was into making websites as a teenager. That was sort of my hobby. That's how I spent like all my time when I was young. But yeah, I didn't choose to go into computer science programming. First, I don't know, back then I felt like, oh, am I a real programmer? Is that really, is it, do I fit in here? Which, now I obviously see very differently. But I did media science and linguistics. And so, I've always been into language. I worked in media for a while. And it took me a while to really find like sort of an area in a field that let me combine all the things I'm into and all the things I'm good at. And I sort of found that in NLP. Which really lets me, combine my passion for software development, for language as well, for making things good, making things usable, making things, work well, building great products. And yeah, so it kind of started when I met my co-founder, Matt, who is also the original author of Spacie. We started working together. At first, I wasn't so sure if I wanted, if it sounded interesting. Like the first time he proposed to me that like, oh, we could be doing something together and I could help him build a visualizer for language. I was like, kind of sounds a bit boring. Like, I knew what this was all about, but I was like, I don't want to do that. I have a job. But we obviously did end up working together, and that's how I started working on the Spacie project.
Awesome. Yeah, no, the more I talk to people on this show, the more I find that almost nobody has what you would call the stereotypical computer science background. Come from all over.
Yeah, no, and I do think machine learning especially is a good field for that, because often, or at least people who are successful often don't just have this very streamlined, oh, I only ever cared about algorithms background. Because, if you really want to make machine learning useful, you don't usually just do it for the sake of machine learning. You usually want to find something out. You want to solve something else. So, I think we're seeing this much more that people come in from a field that they're like really interested in with a problem they want to solve. And then they teach themselves machine learning, get into the field, and then they build stuff.
Yeah, no, absolutely. The interesting problems bring you in kind of regardless of where you started, and then MLs become this powerful tool for tackling them. Agreed. Cool. So, I think we should start by discussing the elephant in the room, which is you've created this extremely popular library with 26 plus million downloads last I heard, Spacie, of course. And what I find very interesting is that you've done this over the years with a relatively small crew of engineers at Explosion, including in the very beginning, as you mentioned, just you and Matthew. So I'd love to hear your thoughts on how you've decided what to prioritize over the years among the probably myriad feature requests that you get.
Yeah, that's a good question. I think we've always, one thing I do think that has helped with Spacie's success as well, that we've always tried to keep a very tight scope on the library. Like it was always clear, what is this library? And that also helps us prioritize what features we want to develop, how the whole thing should work in the first place. So, Spacie A was always intended to be used for production and like real world use cases. So it had kind of a different philosophy there. It's not, many libraries that were developed for research. The idea here is that, you want to be trying out lots of different algorithms. You really want to be working at a different level. It's a bit less important that it runs like super fast and efficiently. It's much more about, covering lots of different areas. And that's like fine too. But we always said, okay, we really want this to build this for real products. And also we want it to be opinionated. We don't want there to be like 50 different ways of doing the same thing, which can be useful in some areas, but like, okay, we really want to say, hey, we want to have one or two ways of doing a thing, and then we want them to be good. That also keeps a good scope. And of course, Spacie is a library for information extraction from text. So, if it doesn't, we don't want to take it to like text generation. There are lots of other adjacent like areas where you can use spaCy, build on top of it, but that, we wouldn't like put in the core library. So.
Yeah, we recently spoke with Thomas Wolf from Hugging Face on the same series, and he mentioned actually the similar idea that having a small team had made it easier to be very opinionated and tight, and that probably helped to prevent it from scope creeping over the years.
Yeah, and also, I mean, to be fair, like most teams actually are very small, or most software products and libraries are actually built by very small teams, even if you look at projects at very large companies. Like people have this idea that like, oh, just because Google or some other large or Microsoft, whatever, publishes something, it means that like the whole organization worked on it. Like, of course not. Or it's kind of like, I don't know, writing a book with 50 people. Like that's, actually actively, that's like a nice art project. Like, but like it usually won't, it doesn't work. It's usually, a much smaller group, even within a larger organization. And, I think the same could be applied for like open source projects.
And you've said before that the design philosophy for spaCy, or at least one of them, is let them code, right?
Let them write code, yeah.
Oh, yeah, let them write code. There we are. So yeah, essentially build this powerful and flexible API, but then let others build on top of it rather than trying to do everything yourselves or sort of put it on a spoon for them. How did that design philosophy come about?
I don't know. That's a good question. I can't think of like one pivotal moment where we were like, it just always felt natural to us, and it just makes sense, and it just felt like okay. It kind of was echoed in how people were actually using the library. It's how we wanted to use software, and basically, the idea is not everyone needs to write code. Like often I feel like people mistake this idea for like something that it's not. The idea is people should be able to program with a developer tool. Or more specifically, you can make very smart API choices that make things simple and only a few lines of code. But the idea is not to just put an abstraction on top of something that's complex. Like, make everything like a click of a button or one function if fundamentally it's not. And I think that's also where a lot of, you see some APIs do this well and work well, and others, try to follow the same approach and it doesn't. And I do think the main difference here is that the abstraction on top of it. Does the abstraction make sense? Does the abstraction let you program? Or did you just wrap something in a function? So you can say, hey, just in, one line of code, do something complex.
Right. Yeah. So, I mean, on the one end of the spectrum, then this sounds like it fits very well for the power user who's very comfortable coding. At the same time, there have been a number of excellent demos that you've put out through the years, including some of the very first work that you did with Matthew around visualizing some of these things. And even your documentation, is quite interactive with the embedded, binder cells and things. So as someone who's built a lot of these sort of, more interactive types of, modes in the past, what do you feel makes that successful as well when it's not necessarily an environment where people are coding?
I think it's when we started building these visualizations, we did have developers in mind initially, because I do think even if you're just writing code most of the time, it's still a very helpful tool. Like you want to look at there's always a difference in like just printing a bunch of stuff and actually looking at a visualization of the output of your model, for example. So that's what initially motivated it. But of course, it's also a great tool to show people something a bit more abstract and break it down and make it a bit more accessible. But I do think it's it's also important to the demo should give you an idea of what is actually going on under the hood. Again, I think what doesn't work very well if you just have some text box and you're like, oh, look at my magical AI doing things. That can be fun. That can be a thing you can build. But I think at least for a developer tool or for something like machine learning, for people who really want to build things, I don't think it's very helpful. And I think it's much more effective to have something that actually shows what is happening here and helps people understand.
Nice. Yeah, one area that I've seen both Snorkel and Explosion very loudly in agreement over the past few years that you sort of alluded to here is this idea that models or real-world problems in general are not one size fits all, right?
Yeah.
That you typically do need some amount of task-specific training data to really get the best performance for problems that actually occur in the wild.
Yeah, absolutely.
Where, in your experience, have you found that to be the most, relevant or the most true?
I think actually in most areas where companies use NLP on a business problem, or machine learning in general on a business problem that has like a lot of value. Like the most valuable and interesting things you can do with that technology are usually very specific. Like companies have a lot of text, companies have a lot of data, and they want to find out something about it that ideally improves their processes, makes them more money, solves some problems they have. And often, the stuff that's easy that you can just, download off the internet, that's nice, but that's also more of a commodity. And the things that really make a difference are the things that are very, very specific to, the business activities and the problems. And also often, real world problems do not often neatly, compose into this like end-to-end prediction system, which is a really interesting research area, and it makes a lot of sense that of course that's what researchers are working on, and that's cool. But often, for a real problem, you'll often have something that consists of multiple parts, and the hard part, or what we see people currently struggle the most with, is taking this problem and breaking it down into solvable machine learning components that you can train, evaluate, that you can also interpret, that you can debug individually, where you can, really assess the quality, potential problems, potential biases in the output, and so on. And I think going from like, okay, we have the bunch of text, we have an internal database, and we want to populate that internal database based on all these documents we've collected over the past 20 years. And then based on that database, we want to, assess whether we should do X or Y. That's very real, but that's also not something that you throw a huge language model with tons of parameters at and like call it a day. You really need to think about how we do that. Maybe you're like, oh, maybe I can predict that. Maybe I can extract that. Maybe I want to add some more manual process here. Maybe I want to add some regular expressions here that my colleague wrote 10 years ago that still work super well. And how does that? So there's just that's the type of work that's where we see what we see as currently, most interesting, most valuable. And, that's also where we obviously want to build tools to make this easier for people.
Yeah, absolutely. That problem formulation component, figuring out how to phrase the problem as you describe it in words into concrete steps and components that get, pipelined together and are individually inspectable.
Yeah, exactly. Yeah. And also I think you can really separate the development part from the business logic part or from the subject matter experts. Like I feel like there are these two different, of course it doesn't work if the machine learning engineer just builds the whole thing without knowing anything about like what, the actual thing is about. That's how also, you've seen lots of these products or AI startups where, someone has this great idea, let's just solve really complex problems in the world with technology. And yeah, of course it doesn't work if you don't understand the actual problem. But on the other hand, I think it's also, machine learning is still quite abstract. There are lots of considerations that require, you to understand how it actually works. And I'm not saying, everyone needs to be like a machine learning PhD, but there are things just fundamentally that I think are very important to understand, also to mitigate problems, because if we all believe that like, you just feed this to the machine and it will perfectly accurately predict it and it'll be right. And that's how you also cause a lot of problems. So I think the solution for that is, you want to bring the subject matter experts and the developers together and work on something. I don't believe that like, the solution will be that like, we should build these systems where only the, subject matter experts can just click through and magically build an amazing AI system. I don't think that's realistic either. It's like, the combination. And then of course, human, machine. Right. And then when that all comes together, I think that's a good formula for, success.
Yeah, I completely agree that these problems, require bringing all these different user profiles into the process somewhere, but there often are different ideal entry points for them, or levels of granularity. And that's where some of this ML systems, thinking and experience is really interesting and an interesting, area moving forward for sure.
Yeah, I think actually that's also where kind of this let them write code idea comes back in again, where, okay, you can have obviously developers program with the tools and put them together. And you can also have people who maybe don't work in machine learning, build some things or build on top of something that someone who can code and, wants to build things has built. Like, I think I often find it very offensive when people talk about like, oh, no code, or like dividing the world up into coders and non-coders, because it, fundamentally, if you look at people, even people who don't program in their jobs, people use complex tooling, people use work tooling. If you look at what, I don't know, an architect does, a lawyer, an accountant, it's not like they sit there and are like, oh, I want to press a button. People do want good tooling. And yes, for some people that means, programming. For other people that means using a tool that was built by someone else. But, I don't think we need to oversimplify things or put weird abstractions on top of it. I do think, we just need to find a way to expose, the capabilities of machine learning in a way that makes sense to everyone.
Well, to wrap up, where can interested listeners find you on the internet? What's the best place to look for what you're up to?
Well, there's obviously our websites for Explosion, Spatie, Prodigy. I'm probably, in terms of work, I'm most active on Twitter, where you can follow me, where I'll be, sharing the stuff I'm working on. I think those are the main channels. Like, I guess I sometimes post on LinkedIn now, but like I don't read any messages on there. It still frustrates me as a platform a bit. But like, I do sometimes post on there, and you can add me.
Sounds good. We'll add links to all those along with the article. Well, thank you so much for joining us today, thanks. Ines. And for everyone else, we'll be back soon with more good discussion about making AI practical.